Hello. This is the demo for assignment 3 collab second. Here we had to I had to create a collab using PyTorch from scratch, and it should be a 3-layer deep neural network for nonlinear function regression problem, and without using PyTorch built-in layer functionality. This is the notebook. So here I'm not using nn.linear or nn.module. I'll be creating my um, mm, layer using very primitive functionalities, and yeah, again, ReLU layer, ReLU for activation, and uh, this is how the layer architecture looks. It takes input, then a hidden layer 1, hidden layer 2, and then an output. Excuse me. So let's see. So for this, the nonlinear function which I have used is sine of x plus some noise to see how the model is working. So this is the data I'll be creating. So here I'm just creating the data using PyTorch's linspace and the formula of sine plus some noise. This is how we got the x and y. Now I'll let me just plot these. So this is how when I plot it, this is the red line is the true sine wave, and the blue are the points which we have created. Excuse me. So yeah, so not everything fits exactly to the line, but we'll try to create a neural network that fits through this data. Yeah, so let's initialize the weights first. So for weight 1, weight 2, uh, uh, weight 1, weight 2, weight 3, bias 1, bias 2, bias 3, we are using Torch's random function and zeros, and then the activation function, and yeah, for this I have put the requires grad equals to true, so that it computes the gradients as it goes automatically, and yeah, then let's define the forward pass. So here, as the assignment mentioned, that we had to create our own layer, not use any NN module. So excuse me. Yeah, so this is how the yeah, I'm using the ReLU for activation. Yeah, so here what I'm doing is I'm creating this x multiplying matrix, multiplying x input, the input with the weight 1, and then adding bias and passing it to an activation. Same is happening in the layer 2, and then we get the output using this, but there will be no activation as it's a regression problem, and we'll get the output. Then let's move to the loss function. So here, as it's a regression problem, we'll use some mean square error. So we'll just use the mean of y predict minus y true, the whole square, and we are not using the torch inbuilt MSE loss function. So this, we have initialized the loss function over here. Then yeah, let's jump to the training loop now. So in the training loop, we'll do the we'll call the forward pass, we'll compute the loss, we'll zero out all the gradients before they before each pass. Then we'll do back pass, which will back propagate and change the values of the weight. It will compute the gradients, and a gradient descent update is where the values of weights and bias will get changed. Oh yeah, so this is how for each epoch I'll run the loop, and first I'll call the forward is yeah, excuse me. Yeah, this is the forward. So it will go through each layer, do the matrix multiplication, bias addition, pass it to an activation, then again in the layers. Then we are calculating the loss for that particular run, and we'll pass the y predict, which we got through the forward, and this y is the one which we created using our equation. then we'll calculate the loss, and we are setting all the gradients into 0. Then we are calculating loss dot backward, which will create just a second. So yeah, we have calculated the loss using our function which we created. So once that is done, we'll just call loss dot backward. So it will it will uh, compute the gradients for us, and once that is done, we are manually updating each parameter. So we will set the gradients to no grad. This will release the gradients, and it will not keep tracking the gradients. It will release the gradients basically, and then we'll, based on the learning rate, and we will change our gradient, our values. And yeah, so these are the after each epoch how the loss is reducing. You can see it over here. And then now I'll just plot, and we'll see how the loss is working. So initially in the 0, the loss was really high, but then eventually with each epoch the loss is reducing. And now let's plot the y predict which we got, and uh, the equation which we had. So the green one is the true sine wave which was there, the blue are the noises, and the red one is the what the network has predicted. So as you can see, it did a really good job in doing that. So yeah, so these are the parameters of the network. But yeah, so this is what I did in this neural network from scratch. Thank you.